Hello everyone, welcome back to my channel. Today we are going to understand an important topic in physics, that is dimensions of physical quantities. And we are going to solve important equations using dimensional analysis and check whether they are correct or not. Now we are going to discuss 1.4 dimensions of physical quantities. First point, the dimension of physical quantities are the power or exponent to which the base quantities are raised to represent that quantity. When we write a quantity using LMT, that is what? Length, mass and time. The powers on them are called dimensions. So here I took an example of velocity, that is LT minus 1. Whatever power is there, no, you can call that as what? Dimensions. So next point, the dimensional formula of physical quantity is expressed by square bracket. So always remember that we have to use the square bracket for representing dimensional formula of a physical quantity. I took an example here, velocity, that is LT minus 1, and force, that is MLT minus 2. Base quantity or fundamental quantity. Now let us see the basic quantities on which all other quantities depends. So always remember that dimensional symbols are written in capital letters. The three fundamental quantities, that is length, mass and time, are the most important to write and to form dimensional formulas. Now let us see the few examples. First one I took, that is area. Area is a derived physical quantity. It tells how much surface is covered. Area is calculated as length into length. Length is a fundamental quantity and it is represented by capital L. So area is equals to length into length, that is L to the power 2. Therefore the dimensional formula is L to the power 2. Then next, here area depends only on length and the power 2 shows it is length squared. So next example, that is volume. Volume is also a derived physical quantity. It tells how much space an object occupies. So volume is equals to length into length into length. Length is represented by what? Capital L. So dimensional formula, it is L to the power 3. Here the power 3 shows volume depends only on length in 3 dimensions. So see the next, that is density. Density is derived quantity. It tells mass per unit volume. Density is equals to mass by volume. Mass is represented by capital M. Volume is represented by L to the power 3. So density is equals to M by L to the power 3. That is ML minus 3. Dimensional formula we got here, ML minus 3. This shows density depends on mass and inversely on volume. Next is 1.5 dimensional formula and dimensional equation. So first let us understand dimensional formula. What it is, see, a dimensional formula is the expression which shows how a physical quantity depends on base quantities like mass, length and time. In simple words, you can say that as which base quantities are used and what powers they have. For example, area is equals to L to the power 2 and dimensional formula, that is L to the power 2. Volume is equals to what we have? Length into length into length. So volume is equals to L to the power 3. Dimensional formula, that is L to the power 3. Now let us understand dimensional equation. A dimensional equation is formed by equating a physical quantity with its dimensional formula. In simple words, we write the physical quantity on one side and its dimension on the other side. For example, volume V is equals to what? You can write it as L to the power 3, or speed, that is u, and force, that is F. So dimensional formula shows the representation using base quantities and dimensional equation shows the equality between the quantities and its dimensions. First, remember one important rule: the dimensions of the left hand side LHS and right hand side RHS must be equal. So I took an equation here, V is equals to V naught plus AT. So V is final velocity, LT minus 1 is the dimension, then V naught, that is initial velocity, LT minus 1, then acceleration, that is A, LT minus 2, and T is equals to time, that is T. So here we have the equation, V is equals to V naught plus AT. So in the place of this equation, substitute all the dimensions. So LD minus 1 is equals to LD minus 1 plus LD minus 2 into. So here 1t and this 1t, it will get cancelled. So the remaining, right, LD minus 1 is equals to LD minus 1 plus LD minus 1. So these two, you can write this as LD minus 1. So LD minus 1 is equals to LD minus 1. LHS is equals to RHS. Hence, the given equation is dimensionally correct. So next I took an example, that is x is equals to x naught plus v naught t plus half at square. So x, that is distance or displacement. So you can represent it that by capital L, and x naught, that is initial displacement. So you can represent that is capital L, and v naught, that is velocity, that is LD minus 1. T is equals to time t, and acceleration, that is LD minus 2. So substitute in all those dimension in this equation according to that in the x place, that is L. Displacement is equals to what? Initial displacement, that is L, plus V naught t, that is LT minus 1 into t, plus half at square. So you can write it as LT minus 2 t to the power 2. So all the time it will get cancelled, and remaining, that is L is equals to L plus L plus L. Then L is equals to L, that is LHS is equals to RHS. Hence the given equation is dimensionally correct. If you like the video, please like, share and subscribe to the channel. Thank you.